Hello everyone, welcome to the video lectures of Nanoelectronics. This is the part 5 of module 5. Here I am going to explain about the Shubnikov de Haas effect. So this is named after the Russian physicist Lev Shubnikov and the physicist from Netherlands, that is de Haas. So Shubnikov de Haas effect is the periodic variation of electric resistivity of degenerate solids, that is metals, semiconductors, etc. with 1 by H, where capital H is the strength of a static magnetic field. Here you need to explain about, or you need to know about, the discrete energy levels based on the magnetic field, that is Landau levels. Very important thing. So look at the figure. Here the x-axis denotes the energy and y-axis represents dose, that is density of states. So what do you mean by a density of states? That is a number of available or valid energy levels per unit energy interval per volume. In the absence of external magnetic field, the density of states or the number of energy states or energy levels will be continuous. Look at the dotted straight horizontal line. It's a continuous energy levels if the magnetic field is 0. If you apply external magnetic field, this continuous magnetic field will split into discrete delta energy levels. These discrete energy levels are called Landau levels. So the energy condensation occurs due to the external magnetic field. Distance between these discrete energy levels depends upon the intensity of magnetic field. The charged particles, that is the electrons, can only withstand in these available energy levels. It cannot withstand in between these energy levels, that is in the gap, it cannot withstand. So Landau condensation in quantum mechanics is the condensation of the cyclotron orbits of charged particles in magnetic fields. I hope everyone is aware about the Lorentz Force, which is the combination of electric and magnetic force on a point charge due to the electromagnetic fields. So in nanostructures, when you apply external magnetic field, the electrons will move in circular fashion due to the centripetal and Lorentz force. As a result, the charged particles can only occupy the orbits with discrete energy levels. This is called the Landau levels, Landau energy levels. These energy levels, mathematically, it is represented as n plus 1 by 2 into h cut omega c, where h cut is equal to h by 2 pi, where h is the Planck's constant, and omega c is the cyclotron frequency. The Landau condensation is directly responsible for the oscillations in electronic properties of materials. Electronic properties means the resistivity and conductivity basically. So the gap between nearest levels is determined by the cyclotron frequency omega c, or it is proportional to the applied magnetic field. Electrons can only withstand or reside at the energies of Landau levels, but not in the gap between them. If you apply a magnetic field into a two-dimensional electron gas, the electrons in the regions perform circular motions, that is due to the Lorentz and centripetal force. But in the border region of the sample, the electrons can't perform full circular motions because there will be scattering. In the part 1, we discussed about the different types of scattering mechanisms, especially the surface scattering and the scattering at the interface of the heterostructures. So the scattering is very crucial in nanolayers or nanostructures. The magnetic field forces the scattered electrons to move in different direction. So there will be change in direction due to the external magnetic field. It will affect the basic electrical properties, that is the conductivity and the resistivity. The period of electric resistivity varies with respect to the magnetic field orientation, or the magnetic field's direction is very crucial. In order to observe this Shubnikov de Haas effect, we need to ensure two conditions. First condition, that is H cut E divided by ME should be greater than K suffix B into T. And the second condition, E into capital H divided by M suffix E should be greater than tau, where H cut is equal to H by 2 pi. We know that, where H is the Planck's constant, E is the electronic charge, and M suffix E is the effective mass of electron, and K suffix B, that is the Boltzmann constant, capital T is the temperature, and capital H, that is the strength of external magnetic field, and tau, that is the electron relaxation time. Electron relaxation time is the time interval between two successive collisions of electrons in a conductor when current flows. So if you ensure these two conditions, you can observe the variation in resistivity and conductivity, that is a Shubnikov de Haas effect in nanostructures. In this session, we discussed about Shubnikov de Haas effect and quantization of energy levels based on the external magnetic field. So quantization of these energy levels are called Landau energy levels. So these are very important questions, very important topics. Thank you.